Hi everyone, welcome to the lesson on the scientific method. I'm Professor Estina, and in this video we're going to explore how science helps us make sense of the world. So what is science? At its core, science is a way of thinking. It's about understanding the natural world by asking questions, gathering evidence, and forming explanations that we can test. The important part, science doesn't deal with opinions or the supernatural. It focuses only on what we can observe, measure, and test in the natural world. So, how is science done? Science starts with observations. That means using your senses or tools to gather information in a careful and organized way. All that information is called data, and it's the foundation of everything else in science. Now, not all data looks the same. There's two main types. Quantitative data is all about numbers, things you can measure or count. So for example, I may say that the patient has a fever of 101 degrees Fahrenheit. 101 is a number, so that is quantitative data. Qualitative data describes qualities like color or texture that you can't put into numbers. For example, the solution appears cloudy and has a sharp odor. These describe what the solution look and smell like. These are examples of qualitative data because it's something that can't be counted. It is a description or characteristic of what you are observing. Once a scientist makes observations, they come up with a hypothesis. That's just a fancy word for a possible explanation, basically an educated guess. But here's the key, it has to be testable. That means we need to be able to collect evidence that could be either support it or prove it wrong. So how do scientists test a hypothesis? They follow a process called the scientific method. It's a series of steps designed to solve problems or answer questions logically. Let's go through these steps. Number 1, ask a question based on an observation. 2, propose a hypothesis, a testable explanation. 3, design a controlled experiment to test it. 4, record and analyze the results. 5, draw a conclusion based on the data. Here are some examples of step 1, observation, and step 2, form a hypothesis. In step 1, you're asking a question about a problem. For example, how much water can a root hair absorb? In step 2, you are making a prediction so that it's testable. For example, the longer the root hair, the more water the plant can absorb. When designing an experiment, it's crucial to only change one thing at a time. That thing is called the variable. Everything else must be kept constant so we know exactly what caused the results. We usually have two groups. The control group doesn't receive the change. The experimental group does. That way we can compare the two and see if the variable had any effect. Let's look at an example. Imagine you're testing a new vaccine. You give one group a pill with the vaccine, experimental group, and the other group a pill without it, the control group. Everything else, the pill's appearance, when they take it, how often is the same. The only difference is the vaccine. That allows you to measure whether the vaccine had an effect. Feel free to pause this video to review this. This leads us to two more terms. The independent variable is what you change, in this case, whether the pill had the vaccine. The dependent variable is what you observe or measure, like the health of the people in the study. Basically, the independent is equal to what you change, the dependent equals what you measure. The dependent variable depends or relies on the independent variable. Step 4, recording and analyzing results. Once you collect your data, you need to organize it, usually in tables or graphs, and look for patterns. Does your data support the hypothesis or not? Then comes the conclusions. Was your hypothesis right? Keep in mind, experiments often need to be repeated many times before we can be confident in the results. Now, if a hypothesis is tested over and over again by many scientists and always holds true, it can become part of a theory. A scientific theory is not a guess, it's a well-supported explanation based on a large body of evidence. I hope this video was helpful to you all, and if you have any questions, feel free to reach out to me.